Okay, hello everyone. Welcome to this session number 468. And today we continue with this problem. It's the top k frequent elements. I solved this problem, but in the time complexity n logarithm n, and the problem mentioned that it's necessary have the solution must be better than n logarithm n. In this case, could be the next or the previous is linear. In complexity chart. Yeah, in this case, this is n logarithm n. The previous or the best option or the next option is the linear. Okay. Now here my idea with this is that yeah, save the indices. Okay, let me use mirror. Submissions. Okay, this. Okay, and K is 2. Okay, now my idea with this is use an array to an array or map. No, a map. Yeah, the first is have. Okay, the first is have one map where appear the digit, yeah, digit and the frequency. Okay, digit and frequency. In this case, for example, the 1 appear one time, another time. For example, the 2 appear 2 times, the 3 appear 1 time. Okay, this is the idea with this map. I think that is it's only enough. Okay, yeah, and every time previously with my other approach, I was using one array of the same length of the original array. In this case, for example, is 1, 2, 3, 4, 5, 6. In this case is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay, and now in every no is n plus 1. Yeah, this case the 0 all the time is empty, and the index it's equal the frequency. For example, in this case the 1 I put here, and now the frequency is 1. Okay, now in the index 1 I put the value. Okay, even you know what, I will use another color for the digit, the revoke color. The digit is 1, the frequency is 1. Okay, in the index 1 here I put the digit. Okay, got it. Now the next dot is 1 again. Yeah, that is this in the index 1. Okay, now have 2. Okay, the frequency 2 is 1. The next is another one. Okay, I increase this, the frequency is 3. In this case I put the digit with this value. Yeah, and with this works, but The problem with this, even let me continue with the simulation. The next that is this is two, sorry, two appear one time. Now in the index one will be the two. Huh? Now the next that is this, the another two, okay, here two times. Now here in the index two is the digit two, okay. Now the next or the last in this case is the three. The three appear one time, okay, in the index one. I need to put the three. In this case, for example, if you see, I have the greater values starting here. Yeah, it's the same length of the this. In this case, for example, is 3. Okay, in the index 3, I can move in this direction, right to left, and discover, in this case, for example, is only 2 elements. Okay, is 1. The first is 1, is the element with the higher frequency, and the next is the 2. Okay, with this works, but the problem with this is that where I have similar frequencies like 1, 2, 1, 2, only that. Okay, and now, for example, 1, okay, is 1, 2, 3, and 4. 1, 2, 3, and 4. Okay, is until here. Sorry. Now, here is the 1 appear one time. Now this frequency in the index 1 is here. I need to use this digit. In this case is 1. Okay, got it. Now the next is the 2. Okay, the 2 is here. The frequency is 1, and in this moment, when I overwrite, appear the 2. Yeah, in this case, for example, in this is 2. Now now the 1 appear 2 times. Okay, in the index 2 I will put the 1, the digit 1, and now the last is the 2. Okay, this increasing 2, and now in the index 2 the value is 1. In this case, for example, appear that only the number 2, but this is wrong because it's 1 and 2. Okay, now for avoid this situation, this is the problem with this algorithm. It's linear, but the problem is that I need to I am losing a few frequencies where have the same frequency. In this case, for example, the 1 appear 2 times and the 2 appear 2 times, and for this reason happened this. Now I had the idea to use no one array because it's expensive, because in every slot I need to create one hash set, yeah, for avoid the duplicates. No, but no. In this case, it's not possible to have duplicates because the frequency in any moment is can't repeat. Can't repeat. Yeah, because for example, if the 2 appear one time is here, in any moment could be appear another time here. Okay. Okay. Now here my idea is first remove this index because it's not necessary. Because again, it's so expensive create, for example, one array of the same length where every item is a list. It's only enough with a list. Yeah. or even with a list. It's enough with a list. In this case, I decide use a hash map for avoid to create many slots and only create meanwhile is performing this operation. In this case, for example, the key is the frequency and this is the digits. The digits. Now, having this, for example, in this case, okay, the first is this, for example, 1. 1 is put here, and now I need to check if exists. It's very similar like the array, but in this case, it's using a hash map. Okay, the frequency 1 is here. No, it's not here. Okay, create this frequency. No. No, 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 no. Okay. Okay. Now is the digit, the frequency. Okay, the frequency is here, and the digit in this case, for example, is 1. Okay. Got it. Until now, I think that is done. Now, the next is this, the 2. Okay, the 2 appear here. The frequency is 1, and now in the index 1, that is this, should be appear the number 2. Okay, these numbers in any moment could be repeat again. It's not possible that appear another 2 here. Yeah, because in any moment I remove any element, or yeah, it's only this. Now the next that is the 2. No, 1 2. The 1 again is here. Now the frequency is 2, and the digit here is 1, and it's done. Now the next, the last is the 2. Okay, the 2 increasing 1. Now in the index 2, that is this, I need to add the I need to add the digit that is 2, and starting for the greater element, because it's the frequency, yeah, in this case is this, take the elements 1 and 2, and obviously this should be, if k is equal to, it's the answer is in this order, 1 and 2. Yeah. Even I think that it doesn't matter the order. Let me check. You may return the answer in any order. Yeah, it doesn't matter the order. Now, the problem with this is that this is, I need to transversal the original. Even I think it's okay if I use this. In this case, for example, 2. Now, I need to transversal this. In this case, this is n. The time complexity is linear. For this operation is constant. For this operation is constant, yeah. But the situation here is okay, I know how. Yeah, the situation here is that, for example, when I have this, I have 1 in the list with the elements, 2 in the list with the elements. But in this case, for example, I know that the greater element is 2 because I am seeing, yeah, I am seeing that this is the value. But in this case, for example, when you don't know, well, the values could be appearing in different orders. 4, 3, because the hash map don't keep the order. Yeah, it's no, don't have any warranty to keep the order. For this reason, I had this problem that the first is sort this element, and next to is iterate over itself. But this is wrong, because if I try to get these values, for example, 1 and 2, and apply the sort, this is n logarithm n, I think. Array dot sort Java time complexity. I think that is this because time complexity. Because use the quick sort. No, array 8, array 8. Java 8 array use this. With modification quick sort name it. Both have some complexity. N logarithm n. And in this case, using this algorithm, basically I am losing the linear time, and now I have the n logarithm n. In this case, this is wrong because here mentioned that it's not possible. But I have the idea that the size of the map, yeah, with the size of the map, I know what is the greater element because it's basically the size plus 1. Yeah, in this case is 2. No, sorry, plus 1. No, it's only the size. In this case is 2, means that the maximum is 2, and I only need to move 2, 1. For example, if the map contains 8 elements, the size is 8. I don't know. Yeah, the size is 8, means that I need to use the 8, 7, 6, 4, and get these values until reach the number of elements that in this case is k. And obviously I can repeat, for example, if k is equal 4, yeah, following this, I can take this 1 and 2, and well, this is not, I can use another 1 and 2 because it's not valid. Okay, for this, I think that we can use a hash set for avoid the duplicates. And with this, I think that it's linear because in any moment I am using any sort in these kind of things. But yeah, because with this, basically where I apply this, I am losing the linear time complexity. Make sense? I think that, I hope that makes sense. Uh, One moment, please. Okay, got it. Now, here I have my indices. Okay, where is complete, I can use a for. Take I, it's equal I, it's equal map dot size. No, it's not map dot size, it's indices dot size. While I is greater than 0, I less is reducing. And the first number, for example, where the map contains 3 elements, is go to the map, get these values, hash set, integer, set equal new hash set, and the result, sorry, the result is this. Now here, oh, okay. I think that I need another 4 inside this, forget all the values. Yeah, another 4, and in this case integer n double point indices dot get, and the key in this case is I, and now is if set dot contains n but negative means that I can use this value result in the position index it's in any order, it's okay. Plus plus it's equal n, and in this case is set dot add, it's add add. In this case I use n, and where result, no, where index, and index it's minor or minor equal. When this, for example, if k is equal 3 and this reach the is 2 and now is 3, it's minor equal. And I think that why its index in this I need to use here, because it's possible that, for example, if I only have one slot but the indices map contains one list with, I don't know, 3 elements, I only need one of them. In this case I think that it's not minor equal minor. Okay, I will submit. And what is the time complexity? Oh my gosh, is no, it's not optimal this. I think that is for this reason. Mm, it's complex, this problem. No. Oh, the problem is here. This. I am getting the indices. Mm, mm, no, and even with this answer of the pretty Q is not linear, because was my first approach, but it's not linear because the pretty Q, the time complexity is n logarithm n. No, is logarithm n, but combine, no, time complexity, and combined with the linear, well, it's n logarithm n. That is not the idea. Mm, no, I think that here the heap is not optimal. Pocket sort. What is pocket sort? I I had the idea to use this even in my previous approach where I think that is this. Uh-huh. Uh-huh. But have these problems with the duplicates. With this, I don't know. Mm. Mm. My gosh, it's hard, but no, no, no. This is not the pretty Q is not one option for the time complexity. Mm-mm. 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 Yeah, I tried with this, but it's not enough. No. Yeah, I had the solution was my first approach, but I would like to solve in linear time. Mm, yeah, if the solution is only reduced to n logarithm k, well, I have the solution, but I think that no. Uh, mm, okay, no, I will check editorial. And logarithm k, let me click q. Quick sort. What is the time complexity of this? Is linear. Okay, let me check the quick sort algorithm because this is easily. This, what is this? Sort. Yeah. Okay. Inner square. Hmm. Okay, I think that I understand much better the code. Oh my god, crazy implementation this. What is the question? Yeah. Logarithm k is mer that k. Hmm. I don't know. I think that is very tricky. The implementation is heavy. Okay, I think that it's enough for this transmission. I think that I follow a good idea, but the problem is that where I duplicate, well, in this moment, um, not working my algorithm. But well, I think that I learned about this algorithm, and yeah, it's all. Thanks for following with this transmission, and I hope see you in the next. Bye bye.